A 1.75 meter tall person walks directly away from a light 5.25 meters above the ground at a steady 1.5 meters per second. We want to find how fast the length of the person's shadow is changing and how fast the tip of the person's shadow is moving across the ground. So a diagram will really help with this. And the diagram will be useful for both parts, but I'll draw it under part A. So if this is the lamppost, or the light, and that's the ground, so we know that this is 5.25 meters up here. The light is shining directly down at the ground here, and the person is just here. So they are 1.75 meters tall. And let's say that the distance here is x, and let's call this distance y. So x is the distance of the person from the lamppost, and y would be the length of the shadow cast. We know that the person is moving directly away from the lamppost, and that would be therefore dx dt, since x is the distance here. So dx dt is 1.5. The length of the shadow is y, so we're required to find dy dt. Now, to get a relationship between x and y here, we can use similar triangles. This triangle here is similar to the whole triangle. So this distance here, which is x plus y, divided by 5.25, must be equal to just y over 1.75. We can rearrange that. 1.75 x plus y is 5.25y. So 1.75x plus 1.75y equals 5.25y. So 1.75x would be equal to 5.25, take away 1.75, so that's going to be 3.5y, and divide both sides by 1.75, so divide that by 1.75, and that's equal to 2. So x is equal to 2y. And that means that dx dy is equal to 2. Now we want dy dt, and that's going to be equal to dy dx times dx dt. If dx dy is 2, dy dx is half. Half times 1.5 gives us 0.75 meters per second. Now part B is very straightforward. We now know that the person is walking away at 1.5 and the shadow is increasing in length at 0.75. So the tip of the shadow here, how fast is that moving across the ground? It's just going to be the sum of the two speeds. If we know the person's moving at 1.5 and the shadow is increasing at length at 0.75, then the tip here is just moving across the ground with the sum of these two. So that's just simply going to be 2.25 meters per second. And we're now in a position to do this exercise in the 3D book.